In this video, I'll describe this third and latest version of the Automated Accu-Slice System. In the previous 8 videos, I described the process of developing the system, going through the various stages of developing various components, the software, the electronics console, and improving the system with each step of the operation. I went through a similar process in developing the Accu-Slice system many years ago. In that process, I actually went through 5 prototypes before we brought it to market. So in this third and latest version of the Automated Accu-Slice System, I made a number of changes to all parts of the system, including changes to the bandsaw, the Accu-Slice index table, the linear ball screw, the electronics console, and the software. All these changes were made to improve the accuracy of the system, to enable the cutting of wider boards, and actually to improve the overall operation of the system. And I'll be describing each of these changes in detail in this video. The only change to the bandsaw was replacement of these front bandsaw table extensions. The previous extensions were 3 inches wide and quite short. These new table extensions are now 4 inches wide and also quite longer. These were made from a piece of angle iron, 4 inches by 3 inches. Iron was used because it must be magnetic in order for electromagnets to operate. The wider extension was needed to give me better support for the larger Accu-Slice system, which was custom designed for this new Automated Accu-Slice system. I'll describe this new index table next. I'm still using the bandsaw table extensions on the left and right side. However, I probably do not need them since I'm using both a 3-foot and a 4-foot rail for this project, but they could be used if I put a longer rail on the system. I totally redesigned the Accu-Slice index table for this project. I wanted a system that uses a linear actuator instead of our standard indexing system used on the Accu-Slice system. I also wanted a system that would slice wider boards. So we'll be testing this system to see if we achieve improved accuracy with this new linear actuator. This is a new Accu-Slice index table which was made for this project. This new Accu-Slice index table uses the same components as our model AS266 Accu-Slice system, with the exception that the guide bars were replaced with guide bars that are about 4 inches longer. This is our standard guide bar, which the plates here slide on these linear bearings. This is about 10 inches long. These new guide bars were custom machined for this project and they're about 4 inches longer. Also, as part of the process, our front plate on a normal system is 1.5 inches wide. This new front plate is 4 inches wide, and I wanted this wider plate to support my linear actuator system, which needed a bigger mount. Also, on our standard system, we used a single linear bearing on this front plate. This new wider plate actually has 2 linear ball bearing guides on the bar. And this combination of these double linear bearings and this wider indexing system should help keep these plates much more parallel to one another and hopefully improve accuracy even more. The standard Accu-Slice indexer was replaced with a new linear actuator from Open Builds. These linear actuators are normally used for custom milling machines, 3D printers, and engraving systems. So I felt that it would be appropriate for this project. Here's another version of the same linear actuator. It uses an Acme thread screw, which is much smoother and should run more smoothly and be more consistent in operating the Accu-Slice system. Also, by being wider and mounted on this plate, these plates should stay more parallel to one another. I mounted this system to the index table by actually turning it upside down and actually mounting this plate with screws to this front plate on the Accu-Slice system. So as a result, it mounts on the system like this, and this front plate mounts to the front plate on the Accu-Slice system, and that moves back and forth to give you your indexing position. Now the thread on this system is an Acme thread, and it's 12 threads per inch, where our standard Accu-Slice system had 20 threads per inch. So I had to make some changes in the software to accommodate this coarser thread, but it should run smoother because it is a much smoother thread. In addition, this linear actuator has a total travel distance of 3 inches, which enable the slicing of boards up to 3 inches wide. Our standard Accu-Slice indexer has a maximum range of only 2 inches. The new Accu-Slice index table mounts on the Accu-Slice system in the same manner as our previous Accu-Slice system, and just mounts in the wider bar slot using these quarter-turn offset cams. For the system I'm making today, I decided to install my 4-foot rail on the system. I could have used either a 3 or a 4-foot rail, but the 4-foot rail will enable me to cut boards up to 24 inches long. And it mounts on the index table, the same as our previous models. Also with the system, I'm using this new 18-inch Accu-Slice 2 index table. This is a new table we just came out with. It's very similar to our standard Accu-Slice 2 table, which was 30 inches long, but this carriage is only 18 inches long. And it will enable me to cut boards up to 24 inches long on the Accu-Slice system. I prefer this Accu-Slice 2, both the 18-inch and 30-inch versions, over our standard carriages because they're more versatile. We have a variety of L brackets and clamps that you can use to clamp a variety of different board shapes and sizes for your various needs. So they're just more versatile than our standard carriages we use on the Accu-Slice system. And again, it would mount on the table in the same manner. I have a plate on here, and with a spacer here, I have a clamp here, just slides under, and then it's in position. The final change I made to the index table was installing larger electromagnets onto the index table. These magnets are about twice the size and actually twice as powerful as the previous magnets. The previous magnets were probably fine, and I saw really not much need to change them, but these magnets are stronger, and I just felt it would make it more stable and reduce the chance of any vibration as the system is running boards through the bandsaw. In the previous version of the Automated Accu-Slice system, I used this linear rail and ball screw, which was 1,000 millimeters long. This size is ideal for slicing long boards. In fact, I could slice boards up to probably 42 inches long with this system. But it is big and cumbersome, and especially when it's mounted on the index table with the 6-foot rail, it's just more cumbersome to take off and on the bandsaw. So I like to go with a smaller system, which is 600 millimeters long. Now with this 600 millimeter ball screw, and with my new 18-inch Accu-Slice 2 system, I can cut boards up to 24 inches long. It's also ideal for cutting my small round disc because it's a smaller system, and I'll be showing cutting those discs a little bit later in this video. I also changed the way I mounted this linear ball screw to my index table. In the previous version, I actually made some clamps to clamp the rail here to the table. But I decided to go ahead and drill holes into my table, and then those holes screw into screw threads into the bottom of these rails. So it's just a much more secure system, and again keeps the system more parallel to my miter bar slot. Both are interchangeable. I can change my 1,000 millimeter onto here. I can swap back and forth because these things are interchangeable. I can either use the screws or clamps to clamp either one on the table. So just because I changed to a 600 millimeter ball screw doesn't mean I can't use my other system, because I can just swap it out. But for most of my applications, this size is ideal. I also created new mounts for my Hall sensors that mount onto the bar on the linear rail. And these just are held in place with a thumb screw that you can adjust them. They can be moved back and forth, up and down. And I have two of these, one on the far end and one on the upper end. And then on the main traveling system here, I mounted a small iron bar, and my magnets are on here. And these magnets are what the Hall sensors sense to control the distance that it moves. I made a few changes to the electronics console. First of all, I added an emergency stop button on top of the controller box. This emergency stop button is a latching switch which is wired to the main power input and will cut all power to the system. This will ensure a quick and complete stop of the operation of the system. Next, I added a pause button. I replaced the stop button that was here previously next to the reset button with a new latching switch, which is used to pause the system when it's cutting through a board. This can be used to pause the system in the middle of a cutting should a problem arise or a minor change needs to be made. Push this button a second time will resume cutting of the board. There is no need to reset the entire system. You can also use the stop button under the run button here to stop the system. With the emergency stop, however, you need to restart the entire system to get any additional operations. In addition, you can also use the reset button to start the entire system. I made quite a few software changes to the system. The first set of changes I made is to the jog buttons. I doubled the speed of the jogging operations just to make it faster when you're setting up your system initially to align your board with the bandsaw blade. I also added an additional step that when this system senses the Hall sensor, it cannot move forward. So as soon as it senses the sensor, it stops. Even though I'm pushing the button, it won't move forward. It'll move backwards, but it won't move any forward. That just eliminates the possibility of it jamming up the Hall sensor. Just an additional safety device. I made a lot of changes to improve the operation of the automated system. In order to accomplish this, a number of software changes were made. First, I changed the order of operation of the indexer. In the prototype version, the system indexed for the next cut at the end of the cut. So I changed the order of operation that the index system will just index just before the next cut. So during initial setup, you adjust the system so that the side of the board is just touching the bandsaw blade. Then you back it up. Then you're ready to start cutting the system. You press the start button. The board will then move the thickness of the board plus the kerf of the blade before it starts the first cut. After cutting the board goes through the system and backs up, and then it'll come back to its final starting position and again get indexed for the next cut. Next, I changed the system that after you finish your cut and before the board is returned to the starting position, the board moves back away from the bandsaw blade about 20,000ths of an inch. And then the board moves back to the starting position and then moves forward that 20,000ths of an inch. This just prevents the board from touching the bandsaw blade on its return travel. And just in case that board could hit the bandsaw blade and possibly move it. So now the board does not touch the bandsaw blade on its return travel. Next, I added some additional steps to move the board further away from the Hall sensor in the starting position. In the initial prototype, I apparently missed a few cuts. I think what happened is that when the board would move up against the Hall sensor, then it moved away from the Hall sensor. And it may not have moved far enough away from the vibration of the bandsaw blade, which caused it to resense the Hall sensor, and so it then re-indexed it a second time. So I changed the operation so that after the board is returned to the starting position, it's first indexed away from the Hall sensor until it's no longer senses the board. Then it's moved an additional 1/4 inch further away from the Hall sensor. In the previous system, the stepper motor for this linear actuator operated at 400 steps per revolution. This means that for every revolution of the indexer, the stepper motor moved 400 steps, or 50,000ths of an inch. Our standard indexer had 20 threads per revolution. This new indexer has 12 threads per inch. Therefore, in order to achieve better accuracy, I changed the stepper motor to operate at 1,600 steps per revolution. This should provide for even greater accuracy of the system. Finally, I added software to sense the pause button on the electronics console. This pause button is the latching switch, much like the emergency stop switch. When this switch is pushed, it locks in the closed position. When it's pushed a second time, it opens the switch. The software was modified to pause the operation of the linear ball screw when it is cutting a board. This will enable the checking for minor adjustment to the system before continuing the cut. Once the system is paused, it can be started again by just pressing the pause button a second time. Now I've described all these changes, it's time to test out the system to see how it operates, determine its accuracy, and see if all these changes improve the operation of the system. I'm ready to do my first set of test cuts, and I set my system to cut a bunch of boards 25,000ths of an inch thick, and I set my blade curve to 45,000ths. And I set my speed to 10 inches per minute, and this is a 1/2 inch blade, 8 teeth per inch, a little coarser blade than I used previously, because I'll be cutting some different type materials. And this is the segmented disc. I think it's 18 segments of a walnut, about 1.25 inches thick. So let me see how many boards I can get out of this, 25,000 inch thick, and then we'll check the accuracy or repeatability of accuracy of the various discs. So the first thing is to set the system up. Let me jog it to get it to touch the bandsaw blade. So there's the board touching the bandsaw blade. Back it up. And I already set my Hall sensors, so they're all set already. So I got to start in, a start and stop position. In fact, let's go automatic right away. And let's go ahead and cut 11 boards. So I'll narrate this as I'm going through, but what it's going to do, it's going to, first of all, advance the board, the thickness of the board plus the kerf, run it through the bandsaw blade. It'll sense the sensor and stop. It'll then move it back away from the bandsaw blade 20 thousandths of an inch. Move it forward to the starting position. Move it back to 20 thousandths. Move it away from the Hall sensor in 2 steps, moving it away and then an additional 1/4 of an inch, and then index it, and then cut the next board. Okay, I cut 14 segmented discs from that disc, and I measured each one as they came off the bandsaw, and they vary between 24.5 thousandths and about 26 thousandths. So really 25 thousandths plus or minus a thousandth of an inch. So a little bit better than the previous system. The previous system was a plus or minus 2 thousandths of an inch. This is more like plus or minus 1 thousandths of an inch variation. But that's pretty good. For this next project, I have some segmented disc. These are alternating, look like walnut and maple, and there's 48 segments per disc. Show close up on this. And my plan is to make some sections, probably 100,000 inch thick, and then I'll glue these back together like a tornado pattern, alternating as I glue it back together. I should be able to make probably like a segmented egg or something out of this with a tornado pattern. Let me first of all attach this to the sled. So my system is set to cut boards 100,000 inch thick. My blade kerf is set to 50 thousandths. My forward speed is 10 inches per minute using a 1/2 inch blade, 1/8 per inch. And my reverse speed is 50 inches per minute. Well, I got 22 discs out of that, each 100,000 inch thick, and I'll arrange these into a tornado pattern and glue them back together. I got a little more variation out of that. I got like 98 plus or minus 2 thousandths of an inch on those, so a little more variation in the previous one, so pretty much comparable to the previous system, so can't say that it's a whole lot better than the previous system that I designed. So it's, again, plus or minus 2 thousandths of an inch variation between the different pieces. This next board is a piece of Wenge, 4 inches by 10 inches. So this is not segment, it's just a solid piece of wood, so you see how this cuts. And let me cut some pieces 50 thousandths of an inch thick off this. I got 6 slabs out of that piece of Wenge, and they all measured 49 thousandths plus or minus maybe 1.5 thousandths. So, but the surface is pretty good, nice smooth surface on it. This next board is a piece of walnut. It's about 4.5 inches wide by 19 inches long. Let's mount this on here and we'll get started. Okay, I reset my all sensors to the maximum position. This is pretty much the maximum board I can get with these sensors with this linear ball screw. It's like about 19 inches. I could get a little bit longer, but I can't. But if I need to get longer, I gotta use the larger 100 millimeter system. So let's cut some more boards again, 50,000 of an inch thick. I did get 9 boards out of that, and they are perfectly straight and parallel from board to board. But the variation in thickness is about 1.5 thousandths. So these came out to like 150 plus or minus 1.5 thousandths. So a little bit better than the previous system, but not a whole lot. But the boards are pretty nice. A nice smooth surface. That 18th per inch blade worked pretty nicely. I'd like to review the summary of what I learned with this new Automated Accu-Slice system. It is slightly more accurate than my previous system, but it's probably not worth the difference in cost, adding these additional long rails, this wide plate, and this indexing system. I think my standard Accu-Slice system works almost as well. It might be, this system might be 0.5 thousandths, maybe 1 thousandths more accurate, but that's about it. But I gave it a pretty good test. We sliced a bunch of discs, 25 thousandths of an inch thick, and they were accurate to within plus or minus 1 thousandth of an inch each. They were really good. Then I sliced these over 20 segmented discs with 48 segments per ring, and they got an error of about 1.5 to almost 2 thousandths variation between the discs. Likewise, I did these Wenge boards, which were like 4 by 10 inches. And the variation of those was about 1.5 thousandths, between each piece. Now they're perfectly parallel all the way around, but from board to board they varied about maybe 1 inch or 1.5 thousandths. Likewise, I did this piece of walnut, which was 4 inches by 19 inches, and again the same tolerance, about 1.5 thousandths plus or minus all the way around. The 600 millimeter ball screw worked pretty well. It's good for doing small boards. But the maximum size I could do was 19 inches on cutting this piece of walnut board. So to use this for longer boards, I need to go to my 1000 millimeter system, and I can cut boards, up to probably 40 inches with that system. So it's much larger. I could have got a little bit more out of this by using a different carriage and a different rail, but not a whole lot more. So in summary, the system worked pretty good. The software changes I made are definitely worthwhile. And actually the changes I made in the electronics console. The emergency switch worked good. The pause works nice. I can pause the system in the middle of the run. And then the software changes I made in moving the board away from the bandsaw blade before it returns, that worked nice. And then moving the system away from the hall sensor at the initial start, I lost no boards with all this testing. For the previous system I lost a couple because it skipped steps. So those systems all work nice. So in general it worked pretty good, but if I had to do it again, I'd probably stay with our standard Accu-Slice system with the regular indexer. This is the standard Accu-Slice system with the standard Accu-Slice indexing system with a motor attached to it. And in reality, it's almost as good as this system. Maybe a little bit, not quite as good, but no more than a half to a thousandths difference between the two systems. I'll continue using this system for additional testing going forward. I'll be running some projects on here for some of the segmented bowls I'm working on. And I'll be showing the system in those videos as I make those projects. But we'll be doing some additional testing just to continue to improve the system, maybe making additional software changes to make it operate more efficiently. Maybe a few minor hardware changes, but probably not that many at this point. If you have any questions or concerns or comments, please give us a call or drop us an email. We'd be happy to hear from you. And once again, thank you for watching this video.